Okay. We gotta work with conjugates. Yeah. So still trying to find like series of polynomial. So now we have complex zeros, basically. Okay. What is a complex number? Okay. Has an imaginary part. So basically I can write complex numbers as a plus bi. This is standard form. So a is the real part, bi is the imaginary part. We worked with imaginary numbers before. Hopefully, anyways. Imaginary numbers come from what? Yeah. So like the square root of -1 is what I represent. Okay. What is a complex conjugate? Now I know what complex means. Most people forget what a conjugate means, though. Yeah. So a conjugate is basically changing a sum binomial to a difference of a binomial, and vice versa. So I'm going to say changing a binomial from a sum to a difference. And it could go the opposite way. So if I had a plus bi, the conjugate would be a minus bi. So basically, we want to talk about complex conjugates because they go hand in hand. So if you see like 1 plus 2i is the 0 of the polynomial, then you automatically assume the conjugate is also 0 of the polynomial. Okay, they have to go together, the plus or minus bi, because complex numbers come from the quadratic formula. The quadratic formula has a plus or minus, so I have to have two imaginary solutions every single time that go together. Okay, so we have two examples. We're going to write a polynomial function, and then we're going to find all the zeros, doing like synthetic division stuff. So find a polynomial function of least degree having only real coefficients in zeros 3 and 2 plus 5. So I can make any random polynomial function. So I know the zeros are 3 and 2 plus I. So is this going to be a quadratic, or what kind of polynomial is it going to be? Has 2 zeros. It listed 2 zeros. Should have 3. What's the third zero? Yeah. So if you see 2 plus I, you have to know the conjugate is also 0 even if it's not listed. So I can write all my zeros as linear factors. So instead of 3, I can write as x minus 3. So that's in factored form. Do the same thing with the 2 plus I, so x minus 2 plus I, and then x minus 2 minus I to represent the other two zeros. Okay. With the polynomial, we never write it like this technically. We always distribute it out to get in general form. So that's what we're going to do. We're going to multiply all this. So I would probably multiply the imaginary parts first, and ignore the x minus 3, and multiply that later. Here we go. X times x is x squared, x times -2. And then x times 5. Okay. Yeah. The other one. And then going to -2, multiplying it. And I'm going to write my like terms together. Yeah. gotta go to the I. Yeah. I'm gonna write minus I squared, but we know I squared is equal to negative 1. Okay. Yeah. So this becomes plus 1. Since I squared equals negative 1. Okay, so then I can add this all vertically, x squared minus 4x. The I parts should all cancel. So once you distribute both the imaginary parts together, you should get something with all real parts. Because we never see a polynomial for an integral form that has imaginary I. Never happens. Okay, so this is what we have now, but we still need to finish distributing, so I need to multiply. My quadratic, got my linear part, x minus 3. So distribute again. We should be good at multiplying. Okay. And then minus 4x squared. Plus 5x. And then distribute negative 3 to everything. So what you got, Maddie? That's good. So not too bad. Just make sure you get the other 0 with it. That's I thought I probably saved those mistakes. So we're getting the other one. Okay. So last one. So we're gonna find all the zeros, knowing that 1 minus I is also 0. So since it's a 4th degree polynomial, we should technically find 4 zeros. Not give it a 1, which is nice. So this might be a hot mess express just because it's 1 minus I. So it says this is 0, it can go in the box for synthetic division. Then we're listing out all the coefficients. Okay. Yes, sorry, making sure those are all right. So we know how to do synthetic division, drop the 1, multiply around. This is where it is kind of sucky because now we're adding like terms, but I get negative 6 minus I and I have to multiply that to 1 minus I. So we're going to go off to the side and distribute. Right, this is where it gets a little bit tedious, unfortunately. Yeah, so I can combine like terms. I squared becomes negative 1. Yeah. Yay. So then I can once again add vertically 18 plus negative 7 plus 5i, which is, yep. And then we have to multiply again. So once again, we're off to the side, doing 1 minus I times the 11 plus 5i, and distributing. Did I do that right? So then it becomes 16 minus 6i. Almost there. So then we're adding vertically again, negative 22 plus 16 minus 6i. Yeah. Negative 6 minus 6i. And distribute again. I think this is the last time we'll have to multiply maybe. Wait, what out? Yeah. So if you multiply correctly, those 6 i's cancel, which is nice. And I have negative 6 minus 6, which is negative 12. So I got my remainder of 0. Which is what should happen since I know 1 minus I is 0. I should have a remainder of 0. Okay. So right now I have like a cubic left over. And if I wrote this as a cubic, I'd have all these imaginary parts, and I don't want to do that because that's just complicated. So what is another 0 that I should know? 1 plus I. So since I knew 1 minus I was a 0, I should know its conjugate is also 0. So we're going to do the exact same thing, just start where I left off and do synthetic division again. So dropping the 1 down, multiplying around them, doing all the things. 1 times 1 plus I is just 1 plus I. So then adding vertically, the i's cancel. Super nice. So I just have negative 5. Multiply it again. And I'm not going to show it out, you just multiply negative 5 times 1 plus I. So you get negative 5 minus 5i. Same thing, my i's cancel. And I just get 6. So multiply again. 6 plus 6i. And they cancel, and my remainder is 0. So I know for sure 1 plus I is also 0. Because my remainder is 0. Okay. So now I have this lovely quadratic. Which I can write it as the quadratic x squared minus 5x plus 6. And this is something I can now work with without all the imaginary stuff with it. So I can figure out what the zeros are by factoring. Anybody have an idea of those factors? Okay. So negative 3 and negative 2 multiplied by 6, add a negative 5. So, okay. So based on that, what's the zeros from that? 3 and 2. So those are the real zeros. My complex zeros I can write as 1 plus or minus I, the parts that I did synthetic division on. So I did get out 4 zeros, which is what I should, because it was a 4th power polynomial. Nice. Good. Good. Awesome.